Hello wonderful person, this is Anton, and today we're going to be discussing this relatively new and somewhat intriguing paper that might have discovered something really unusual about the universe, something that nobody expected. The universe, or at least the early universe, might have not really been symmetric, or in other words, it seemed to have some kind of a preference in terms of what we usually refer to as handedness, or symmetry. Or to give you, a slightly better, more realistic explanation, if we were to create a bunch of stuff in the entire universe, we would assume that the equal amount of inverse or mirrored stuff would exist as well. So for every particle you'd find an antiparticle, and for every particle-antiparticle pair, they would essentially resemble mirror images. Although in this case, this particular mirror image can refer to any property. Here's an example of a mirror image of charge, with the expectation being that we generally expect the universe to have both in equal amounts in order to basically make sense. But in particle physics, there are other types of symmetry, including something known as parity, which to some extent refers to handedness, or which way a typical particle would be spinning. And so overall, for many years, scientists expected all particles to basically be symmetric in every single way. But in physics, there's also something known as CP violation, referring to certain unique violations of symmetry in certain types of particles. We've actually discussed this in one of the previous videos, but there was a discovery back in the 60s that eventually led to the Nobel Prize, with the actual story being a little bit more controversial, with the main point being that CP violation, or the violation of the symmetry, seems to exist in certain subatomic particles around the universe. But if you want to just read about this, you can also read the article about the so-called Wu experiment. This is a pretty intriguing story, and in essence shows us that something is actually going on in the universe after all. But in this case, this was very small scale, as in it showed us that certain particles seem to have violation of symmetry, but the vast majority out there seem to not. Most of the stuff seems to be symmetric. And by itself, this presents a small problem. The problem being that, how do we explain how everything actually exists? Or basically, why are we even here? If the majority of stuff out there is symmetric, and if all particles are actually equal to their mirror images, and they were produced the same way in the beginning of the universe, well, in that case, Big Bang should have produced equal amounts of everything in the universe, and that includes matter and antimatter, and it would only exist for a fraction of a second, annihilating and leaving energy behind. Or just to rephrase this, if the entire universe was actually symmetrical everywhere, technically everything should have been gone a long time ago, with all the particles annihilating in the process. If symmetrical, the universe should have produced an equal amount of matter and antimatter, and so something here just doesn't add up. Even though a lot of things in the modern universe seem to be symmetric, maybe this was not always the case. Maybe the early universe was asymmetric, thus explaining how matter was able to survive so long, and why there is more matter than antimatter, with everything eventually becoming symmetric over time. And that's of course something that has been confirmed. For example, we know that all electromagnetic forces seem to be symmetrical, and no asymmetry has ever been observed. But we also know that electromagnetism did not exist for the first few moments of the existence of the universe, with the electromagnetic force even connected to something known as the weak force, which we know contains asymmetrical features, which already hints at the potential asymmetry of early universe. But all of these so far are just hints and just theories. Is there any physical evidence? Do we have any evidence for any of this, or is it just as theoretical as dark matter? And it looks like the paper behind me points at this really strange evidence, something that currently has absolutely no explanation. So let's discuss this in a little bit more detail, talk a little bit more about how this was discovered, and what ramifications this might have. First of all, the title here is obviously a little bit long, but in a nutshell what the scientists did here was sort of intriguing and really interesting. They essentially realized that when it comes to mirror images, or basically parity, the most simple three-dimensional shape whose mirror images are going to be different is a tetrahedron. Or in other words, a tetrahedron is the simplest possible shape that cannot be rotated into its mirror image in 3 dimensions. The simplest 3D shape that has unique mirror images. And so the scientists behind this paper wanted to see if, well, hypothetically, can we actually discover a bunch of these tetrahedrons out there in the universe and see if the overall amount of them is going to be more or less equal, basically left-sided or left-handed and right-handed, or if there's going to be some kind of a preference. Is there going to be a larger number of, let's just say, certain tetrahedrons compared to other ones? Just for the sake of simplicity, let's call them left-handed and right-handed. And obviously modern theories and modern understanding of the universe suggests that they should be equal. No matter where we look, we should see equal amounts. And that's independent of what we look at. And so how do we even look for these tetrahedra out there? Obviously, we're not going to be able to find specific shapes or specific stars of this shape. Well, what they did was kind of brilliant. They realized that you can actually connect this to various galaxies, specifically distances to galaxies compared to one another. In this case, this tetrahedron is formed by 4 separate galaxies, with the distance between each galaxies represented as R1, R2, and R3. And as you can see from the formula, R1 is the smallest distance, R3 is the largest. Or just to rephrase this, they looked at quadruplets of various galaxies out there. And the only thing that they had to know about these galaxies was the overall distance between them based on various redshift calculations. But to make calculations and observations much easier, they focused on galaxies known as LRG, luminous red galaxies, and specifically 280,000 such galaxies from the Baryon Oscillation Spectroscopic Survey and 800,000 other observations from a slightly different survey that was conducted by the same program. So basically they looked at over a million very bright galaxies whose properties were quite well known. And then they created these hypothetical 4-point correlation functions out of all of these galaxies. This actually created something like million trillion different possibilities, all based on 3-dimensional vectors formed by individual galaxies. Now once again, in theory, we should expect pretty much equal amounts of these left-handed and right-handed tetrahedra, no matter what kind of galaxies you look at, no matter where they're located, simply based on the idea of random distribution of matter across the universe. Now there might be some chunks slightly more concentrated than others, but as you average everything out, it should be more or less equal. But once they applied mathematical analysis to all of this, they discovered that in the first sample, the actual evidence for non-symmetry was really significant, specifically 3.1 sigma, which is already a huge discovery when it comes to new physics, with the second sample producing something even higher at 7.1 sigma. And none of this can be explained by modern theories of gravity, any kind of evolution of the universe, expansion of the universe, or even more hypothetical, less accepted theories. Or just to rephrase this, there is absolutely no explanation for why this was detected. No idea why there seems to be symmetry when it comes to galactic distribution. However, they do believe that this is maybe something that happened right after the Big Bang, potentially during the inflation period and before the fundamental forces became the way they are. And so as the universe suddenly expanded, for some reason, it seemed to have some kind of a preference for certain symmetry. And then, as the universe evolved over time, and as things like cosmic web provided the foundation for new galaxies, over time all of these new galaxies started to position themselves in what seems to be preferred type of a symmetry, creating a kind of a symmetric imbalance. Although the actual source of this symmetry is obviously unknown and will be currently impossible to determine. And because of this unusual, somewhat groundbreaking discovery, it's also important to talk about potential errors. And while in terms of errors, there might be some bias here, as in observational bias. So far this is all just based on the release from SDSS and just 1 million galaxies out there. We've actually discussed this previously, but the release from SDSS so far only covers this much of the universe. So basically it doesn't cover the entire universe around us, mostly because of the way that these telescopes work, where they usually look during nighttime, and how certain regions become somewhat unavailable. And so in theory, maybe it's just in these locations that things are slightly more sided. Maybe if you look here, for example, or over there, the actual sidedness will suddenly disappear. But at the moment this is really the only bias I can think of, and the only problem I found in this particular interpretation. There is, however, a solution to all of this in the future. Other galactic surveys, such as Dark Energy Spectroscopic Instrument, or ESA's Euclid telescope that's going to be launched sometime in 2023, are extremely likely to provide even more data to either prove this and find even more weirdness, or completely disprove this and discover where the mistake actually was. And so whether this was just bias that can be resolved by these telescopes, or whether this is actually something fundamental discovered here, we'll unfortunately only know in time. But until then, this is a pretty big discovery, and actually a somewhat unusual discovery that doesn't really have a very good explanation just yet. But the implication here is that if the universe was handed in the first few moments of its existence, it seems to be still visible today, and more importantly, it might finally explain why we're even here, why matter prevailed over antimatter, and why physical objects were formed over the last 13.8 billion years. But what other implications this has, I currently have no idea. It's actually a pretty big discovery, assuming that it's real. And so I'll definitely follow this up once there is more information, more data, more explanations, or once there is some other really cool explanation to why exactly galaxies seem to form this unusual handedness. Until then, thank you for watching, subscribe, check out all of the relevant links in the description below, where you can actually also find other unusual discoveries related to symmetry or unusual lack of symmetry in the universe that we've discussed in the last few years. Maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. And either way, stay wonderful, I'll see you tomorrow, and as always, bye bye.